Natural fertilization is that biological process where the male gamete, sperm, meets the female gamete, egg, giving rise to a new life, which will develop in the 9 months of pregnancy. However, when conception cannot occur naturally because the couple has problems having children, various assisted fertilization techniques can be used. We have seen what assisted fertilization is, how artificial insemination and in vitro fertilization works. Let us now return to how natural fertilization occurs. The best time for conception is during the woman's fertile period, that is, during that phase of the menstrual cycle in which the chances of becoming pregnant are greatest. In general, the most favorable days for conception coincide with ovulation and the period immediately preceding it. Ovulation is a phase of the menstrual cycle and, on average, corresponds to the 14th day of a regular 28-day cycle, while the fertile window will begin as early as day 10. The length of the menstrual cycle can be influenced by several factors and therefore varies from woman to woman. During ovulation, the ovum, i.e. the female gamete, reaches maturity and is expelled from the ovaries and released into the fallopian tubes. It is precisely here that following unprotected sexual intercourse, the spermatozoa contained in the man's seminal fluid arrive. They move through the cervical canal to the uterus and reach the fallopian tubes, where they meet the woman's egg and fertilize it. Millions of spermatozoa enter the vagina following ejaculation, but only 100 reach the tubes, as the others die during the journey. Only a spermatozoon can penetrate the egg to fertilize it. Immediately after its entry, it creates a barrier around itself that prevents the entry of other spermatozoa. How does the encounter between the sperm and the egg take place? The sperm head is covered by the acrosome, a cap-shaped structure that contains several enzymes that have the ability to fuse the cell membrane of the sperm with that of the egg. The ovum, on the other hand, is covered by a protective membrane called the zona pellucida. It is composed of 4 glycoproteins, which play a fundamental role during oogenesis, fertilization, and pre-implantation development. The ZP3 glycoprotein functions as a receptor in the zona pellucida and has the function of binding the spermatozoon to the zona pellucida of the ovum. At this point, the acrosome reaction can begin. ZP2 glycoprotein is a structural component of the zona pellucida and plays a secondary role in the penetration of the sperm after the acrosome reaction. The membrane surrounding the acrosome fuses with the plasma membrane of the zona pellucida, exposing the contents of the acrosome. It contains surface antigens and numerous enzymes that allow the membrane of the egg to break and allow fertilization. Once the spermatozoon has entered, a specific enzyme cuts the ZP2 glycoprotein in order to prevent the penetration of other spermatozoa present outside the egg. Furthermore, changes occur in the zona pellucida, which make it no longer penetrable. The egg is able to be fertilized for less than 24 hours after its release in the fallopian tubes, while the spermatozoa can remain viable in the female genital system for up to 72-96 hours after intercourse. In some cases, the woman produces in a month not 1, but 2 eggs, which, if both are fertilized by 2 spermatozoa, will form 2 zygotes and the development of a twin pregnancy. From the encounter between the sperm and the egg, the zygote is born, the first cell of the child, which over the course of 9 months will give rise to a new life. The zygote has 23 maternal chromosomes and 23 paternal chromosomes, which will determine the genetic makeup of the child. The cell already knows what the color of the child's eyes and hair will be, his height and face shape. The sex of the unborn child depends on the chromosome that donated the sperm. What does it mean There are two sex chromosomes designated with the letters X and Y, and they are decisive for the sex of the individual, which depends exclusively on the genetic contribution of the father. The sperm contains both the X chromosome and the Y chromosome, while the egg always contains only the X sex chromosome. At this point, there are two possible combinations. If the egg with its X chromosome merges with a sperm containing another X chromosome, a girl will be born, while if it encounters a sperm containing a Y chromosome, a boy will be born. At this point, the zygote will begin a series of cell divisions, dividing first into 2 cells, then 4, 16, 32, 64, and so on. It moves towards the uterus, where it adheres firmly to the endometrium, mucosa that lines the walls of the uterine cavity. Thus occurs what is called embryo implantation and usually takes place between 5 and 6 days following the fertilization of the egg, starting the actual pregnancy. To find out what happens during pregnancy, week by week, month by month, I leave you the 3 videos I made above.